Oh, we're recording.
Let me make that there. Oh, yeah, I am recording. So, I thought I'm gonna go over a few. I might as well get this up here, especially with all the sickness lately. And I know that maybe not everyone watches the videos when they're supposed to. Nothing. Sorry, I had a little creak in my neck. I know it sucks. Sorry. So I say problems 1, 2, and 4. I don't really want to do 3 because I feel like it's just like, but 4 changes it up a little bit. So I thought we'd go over the first 2 and then number 4. Let's get to it. So, problem 1, what do we, well, for any problem, what do we do first? Yeah. And honestly, we don't really need C, but let's do A and B. Um, so A is what? 2 for sure. So A is 2. What's B? Good. And so we're not using the quadratic formula, so we really don't need C. That 48 will come into play, but not for another minute or so. So who remembers from Thursday the formula for finding the x coordinate of the vertex? Well played. Yeah, good job. So opposite of B divided by double A, and it gets harder as the problems get more fraction-y, but is what it is. So what's the opposite of B? And then what's 2 times, in this case, A, 2 times 2? And what's 20 divided by 4? Yeah. So that is the vertex, but it's the x coordinate of the vertex. We know it's located at 5 something, right? We just don't know what the something is. So A and B have served their purpose. Now it's time to find the y. And how do we find the y? Plug it back in. So you just take your little 5 and you put it here. And you put it there in those little purple circles. You just change them into 5 and hope and pray that nothing bad happens. So for the first little purple circle, make sure you follow the order of operations. What's 5 squared? And what's 2 times 25? Nice. And then I'm going to put minus. And what is 20 times 5? 100. Now you do the math. What's 50 minus 100? Negative 50. And then negative 50 plus 48. It's negative 2. And we made it. So problems like that should really kind of be pretty walk in the parky, no fractions to deal with. Just some simple basic-y stuff. So what's that? Did you say something? Really? Man, that's weird. Okay, good. So that means that we can go to the point now, 5, negative 2, and we can now begin the process of graphing. So my vertex is at the point right 5 down 2. So boom, make a little dot there. Now, remember on Thursday that we learned that now a good part of this equation has served its usefulness, like it's used up all of its usefulness. Remember that all of the stuff works together to get us the directions to the build site, and we made it. And once we get to the build site, then we no longer need anything other than the number that's in front of the x squared. I hope that's ringing some bells. That's the guy that tells us how to build the parabola. He's the guy that tells us, does it open up? Does it open down? Is it skinny? Is it fat? And sometimes the math is a lot easier. This is a warm-up-y problem on a lot of levels. This is another one of those levels. So remember that the act of finding more points is a matter of going out 1 and up something, out 2, up something. Like we just keep doing that. What are the normal numbers that we talked about last week? What are our, if I were to change nothing numbers, what would we do? Out 1, up 1, out 2, up 4. 2 squared is 4. Out 3, up, out 4, up 16. Remember what the number that I have not destroyed up there, the one that's surrounded by the death globs of red, the number 2 says to take your normals, your 1, 4, 9, 16, 25, 36, and multiply them by 2. That's what he does, is he increases your growth rate times 2. Makes your parabola look more skinny. So when I leave my vertex and I go outwards 1, I will not go up 1. As per the default, I will go up 1 times 2, which is 2. When I leave my vertex and I go out 2, under normal circumstances, I would go up 4. But I'm going to go up double 4, which is 8. So I'm going to leave and go out 2, and then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And remember, if you find 1 point, you should always plot 2, because they're going to be the same on the left and the right sides of the axis of symmetry. And this will eventually become the hardest part. Like you might think that's not really true, but eventually once you figure out all the math, then graphing the actual curve is generally pretty difficult. Like to recap, there's 3 ways to lose points on these, and I'm not going to be, I don't mean to critique like your drawing skills, because I'm a very poor artist, but when it comes to math, there are 3 things that you cannot do when graphing these. So I'm going to run through them with you really quickly. 3 ways to lose points when someone asks me to graph a quadratic. Here comes method number 1, and that is straight lines. Sorry, you can't have straight lines. These are curves. Curves like this are never going straight like a line, ever. They're constantly increasing or decreasing their slopes. And so that's one way to lose points. You guys remember the other ways that we talked about that you could get gooned on points? Yeah, that's another one. And that kind of goes with the straight line. So if your bottom looks like this, you're going to get gooned. That kind of goes with the last one I said. These are never like straight and jaggedy. Okay, you'll see that when we do absolute value graphs, they're V's. These are not. So yeah, no straight stuff on these. Another way to lose points is to have the curve start looking pretty good like this and have it double back on itself. If I even see any inkling of your parabola starting to recross over itself, you're going to lose a point. And it's not because I'm vindictive, it's just because I want you to do this right. And functions do not double back on themselves. Quadratics, parabolas never double back on themselves. So any inclination for it to start to look like a horseshoe, and you're going to lose points for that. Anyone remember the third one? Right, if it's got like wings. So again, you might have the greatest of intentions, and you've got this graph, and you feel like, wow, I'm getting really good at this whole curvy thing, and then at the end, I see your graph go like this. Sorry, I'm going to take points off. Like it does not curve in on itself like a horseshoe, and it doesn't go out like a bird with wings. So the issue is, how do I make it look right? And what I find is the easiest way is to just sketch it lightly with your pencils. And it's hard for me because I've got this digital thing that's not very, it's kind of on or off, ones and zeros here. But uh, I would start with just a little bit of light sketching like that. And once you're happy with it, then you can kind of go full send on it, commit. And the more you go over something like this, it's an old artist trick, is that if you kind of keep going over something, you can start to work out imperfections as you go. So I find that if I do that with my pencil and I'm coming up here and I kind of start to like the way it looks, and then once I'm feeling like I got it, then yeah. And you'll know when you get it, it'll look smooth. It should always be curving. And I still struggle, having taught this for a long time, as you know, I still struggle with um, this art of making a curve. And you will also struggle more on these kinds of parabolas, the taller, skinnier ones, because those long shots from Y to Y are very hard to make look good. So just go over it again and again until you can say, have I broken any of the 3 rules? Like, don't hand it to me and say, does this look okay? I mean, I'll look at it, but if you got straight lines on it, I'm going to say fix it. If you got wings, I'm going to say fix it. And if you got even a little bit of horseshoe, I'm going to say fix it. So check those 3 boxes there. Any questions on number 1? Okay, the difficulty jumps significantly when we get to problem 2, which is funny to say in a high school class, but really it's all just because of the fraction. And unfortunately, we live in that world where fractions are rough. So let's get to it. What's A? Just 2/3, no x squared. Just the 2/3 is A. What's B? Just the -4. Very good. Okay, now we go to our formula. Cooper already gave it to us once. It's the opposite of B divided by double A. So show lots of work when you do this. Go off to the side somewhere, scratch paper, whatever, and be generous with how much work you allow yourself to do. Like, don't miss it because you're trying to be like, ooh, look how fast I am, Mr. Fancy Pants. No sense in that. So the opposite of B goes on top, and that is, well, 4. And then on the bottom goes the answer to a little baby multiplication problem. And 2 times A is, I'll write it down here, is 2 times 2/3. And what is 2 times 2/3? 4. So I'm going to put 4/3 up into my fraction. Now, remember, fractions really are just division problems, right? If you've never studied it before, the sign for division is literally a fraction. Like that line with the 2 dots is a fraction, for God's sake. So when I see a division or a fraction, I know that they're interchangeable. So I can think of this as copy dot flop. So someone says to me, hey, I need you to do 4 divided by 4/3. My brain immediately switches into, oh, you mean 4 times 4/3 flipped over like that. So anytime you have a fraction on the bottom, it's really like division by a fraction. You turn it to times and flip that fraction over. And then, of course, you're like, ooh, sweet, the 4's cancel out. What then is the final answer then? It is 3. So after all of that, we're left with a conclusion. And that conclusion is that the vertex of this parabola has an x-coordinate of 3. It's a lot of basic skills-y work to have to get through to get there. How are we going to find the y? Yeah, go change those x's. Go swap the x's out for 3's. So there's one x right there, and there's another x right there. If I make this first one into 3, what is 3 squared? And again, basic skills question, what is 2/3 times 9? It is 6. You ask people, how'd you get that? There are 3 things they'll say if they got it right. Number 1, I used a calculator. Number 2, I reduced and then multiplied. Number 3, I multiplied, then reduced. Like, those are what you do. So in this case, you could take like this 9 and this 3, reduce them both in your head down by 3. You get a 3 and a 1. 3 times 2 is 6. Or you can say, to heck with that, I'm just going to go straight across and do 2 times 9, 18 divided by 3. Doesn't matter how you slice it, you're going to get a 6. I don't know why I put that there. Don't put that there. So the answer to this portion is 6, right? And the rest should be smooth sailing, right? If I put a 3 in the second little purple circle, what's 4 times 3? Yeah. And then what's 6 minus 12? -6 plus 6. Made it. So that's just the vertex, but honestly, that really is the lion's share of the work. There's a little bit of basic math coming up, but nothing like that. Finding the vertex is usually the pain. So let's get to it. Once again, I would implore you to consider, and I don't really want you doing this on your test because it might muck up my ability to see your work. But as the guy up here who's trying to show you this, I would say the only thing I care about now is that number that I have not destroyed. Remember, he's the boss, the builder. He says 2/3 is your guy. So we're going to take all of our normals and we're going to modify them by a factor of 2/3. So again, the normals are 1, 4, 9, 16, 25. So I'll write down the normals first and then we'll modify them. So normals are 1, 4, 9, 16, 25. Who knows how many we'll have room for. So here we go. Basic math. What is this number in the box up here? 2/3 times 1. 2/3. Okay. Sorry, more basic skills incoming. What is 2/3 times 4? It is exactly 8/3. I love how quick that was. What is 2/3 times 9? No. 6. What's 2/3 times 16? Perfect. And at this point, we're already over 10. We're not going to have room for any more. Those are Y values. Those are vertical jumps. Clearly, if we did 15 or 25, we'd have 50 over 3, which is almost, what is that, 17. We're not going to have room for that. So I could stop there. I don't even know, quite frankly, I don't think I even have room for that one. So here we go. Remember, it's out 1 and then do the number, then out 2 and then do the number, and then out 3 and do the number. Never mess with your outs. Always go out 1 and then do something. Always go out 2 and do something. Don't ever modify those. Not yet. Good. So let's get to it. Let's go plot the vertex. So I'm going to head over to the point 3, 0, and he is right there. Oop. And now it's time to build. Does this graph open up like a bowl or down like an arch? Definitely up, because the number in the red box is positive. So he's going to say he's the bowl, right? Go upwards. So I'm going to go out 1, and then I'm going to go up 2/3, because that's 2/3 of the normal. And this is not a perfect thing. You just kind of estimate where you think 2/3 of the way is. Do your best. Just don't do something knucklehead, like put it at the halfway point or below halfway. Like those would be pretty kind of, what are you doing? We go out 2, we would normally go up 4, but we already did the math that we go up 8/3. And let me go modify something for you down here. What is 8/3 as a sensible, like a mixed number? 2 and 2/3. Very good. So we're going to go out 2 and up 2 and 2/3 of the way to 3. And we can fit one more, because we're going to go out 3. We would normally go up 9. We're going to go up 2/3 of 9, which is 6. We already did the math. So we're going to go out 1, 2, 3, and then go up 1, 2, 3, 4, 5, 6. That's a pretty standard looking parabola. Obviously, we can't go again, because if we went out 4, we'd have to go up 10 and 2/3. And the highest this graph will allow me to go is 8. And so there's really no, that's my rule for you, is going to be plot as many points as the graph will hold. As you saw in problem 1, that meant 5 vertex and then 2 on the left and 2 on the right. Sometimes it's going to mean 3 vertex and 1 of each. Sometimes I think I've seen somewhere I had like 11 or 13 points. So you just fit what you can and then stop. But do fit what you can, please. So again, the idea is, let's go make a sketch, and remember to maybe start with the bottom and maybe give it a little curvature down there. And then let the games begin. Remember, no horseshoe effect and no wings like a birdie. You're welcome to criticize mine whenever you want. Like if you see something, just call me. You're not gonna hurt my feelings. But like I would give myself marks, full marks for that, and say, good enough. You didn't break any rules. You don't have the straight jaggies, you don't have the wings, and you don't have the horseshoe. So good to go. So far, so good. All right, let's take a look at question 4. Oi, hello. Maybe. Okay, I don't. So you're welcome to hang around though. But I'm recording and I gotta help these guys. So yeah, whatever. You good so far? All right, let's get to it again. Third verse, same as the first. What is A? -1/2. What's B? 5. Good. Is everyone clear that we're on problem 4, right? I did skip 3 because 3 was too similar to. I wanted this to be a couple new things, so I went ahead and skipped 3. So first step is know your formula, and having to go somewhere and say, gosh, I forgot the formula, that's really going to be pretty crippling for us. So opposite of B divided by 2A, and what is the opposite of B? So I'm going to put -5, and then on the bottom I'm going to put 2 times A. What is 2 times A? And what's -5 divided by -1? Good. So at this point, we can at least make a commitment and say that the vertex has an x coordinate of 5. Any questions there? Get her done, bud. It's like tearing off a Band-Aid. You just gotta, there you go. Okay, so let's go find the y to go with it. And that means we're just gonna put the 5 where these little purple circles are. So there you go. Let's do the first purple circle. What is 5 squared? Good. And what is -1/2 times 25? Good job. I like how quickly you attack those. You don't second guess yourself. You just know that if it doesn't work, make it a dang fraction and move on with your day. That's good stuff. I appreciate that. And then if I put 5 into the center purple circle, what's 5 times 5? 25. And then at the very end, I've got minus 31 halves. So what's our thinking at this point? I got a very interesting answer from a young man, second hour. I really liked it. Sits right next to that young lady over there. Thoughts? Sorry if you said it, I was talking and I didn't hear you. Yeah, that's what he said too. I like the way you guys think about that. That's good. Yeah, put the fractions together. I was going to say if you wanted to, you could take the 25 and make it a fraction, but I like what you're saying. So let's take these two fractions and just add them together because why not? If you add those, it's nice that they both have twos on the bottom, and it's even nicer because they're both odds on the top. And an odd added to an odd is an even, and an even divided by 2 is a good thing. So add those together. What's -25 tooths and -31 tooths added together? So I don't want to skip any steps. Thank you. So it is -56/2. Everybody good? And then yes, of course, at that point, having an even number divided by 2, I would, of course, simplify that down to be -28. So that's why it's a pretty superstar move in that case to put the fractions together because they do knock each other out kind of. They go back to nice numberville. And so that's -28 plus 25, which is, and there is our vertex. Okay. Whew, we made it. So now that you know the vertex, yet again, it's time to focus your attention on only what it needs focused on, and that is the part that I have not vandalized. What does that tell us? That tells us two things, that A value. What does it do to the graph? It's going to go down, and what else is that going to do to it? It's actually going to get fatter. And it's weird that it does that. But the reason it feels like it gets fatter is because the y values are cut down by half. So if you think about it, when we go out one and down half as much, those points stay higher longer, causing that arch to be a little bit chunkier. So it goes against what your common sense tells you. You feel like a fraction would make it get tighter, but it actually is the opposite. Fractions make fatties. Okay. So I'm gonna go graph the vertex first. I'm gonna go right 5 and down 3 and put a big old red dot there. And again, mostly for the benefit of anyone who wasn't here on Thursday, let's go as a team and list out the normals. Remember, the normals are what we would do if that number, the half, the -1/2 wasn't there. The normals are I would go out 1, vertical 1. I would go out 2, vertical 4. I would go out 3, vertical 3 squared, right? I would go out 4, vertical 4 squared. Out 5, vertical 5 squared. People ever say to me, like, I keep forgetting these numbers, then my comeback is, well, get good, noob. They're just 1 squared, 2 squared, 3 squared, 4 squared. I mean, they are squares. That's all. Okay. So we can come up with them on the fly. Then we modify them based on the number up at the top of the board. I don't have a box around it, but it's the survivor up there in the pool of red. And so he says to cut all those dorks in half. What's half of 1? a half. And you could put negative, or you can just rest assured that they're all going to go downhill. I would leave that up to you at this point. So the negative really serves only one purpose, and that is just to make all this stuff happen downwards. So put it, don't put it, it's up to you. Just don't forget. So what's half of 4? What's half of 9? And it's okay in this case to just put 4.5, because that's probably going to come in handy anyways. What's half of 16? Half of 25? Or again, 12.5, whatever. And so at this point now, I know how far down to go every time I take a jump out to the side. I'm not saying right and I'm not saying left, because like both, right? You pick. So out 1, down how far? A half. Out 2, down how far? Correct. And we're obviously out of room because we've run out of horizontal spacing for one thing. So out 3, down half of 9, 4.5. So out 1, 2, 3, down 1, 2, 3, 4.5, like that. And you will always, unless you're a real weirdo, you'll probably find that these the chunkier graphs are the easier ones to graph. They just are. They feel there's more room for forgiveness on these. You don't have, so that those long stretches on those tall, skinny ones, man, those are hard to not give them wings or horseshoes on. Super hard. And as I can attest to, having done this for a long time, it's one of those things that unfortunately doesn't just get a lot easier. Like there's no magic wand. Sometimes you nail it, sometimes you got to go back and try it again and again and again. Hopefully, for those of you that were here, as well as those of you that were not here, that all makes sense. It's just a process. You do your negative b over 2a first to find the half of the vertex. Pray to God that goes right. Put that answer back in for x to find the y. And then go to that point, make a graph. That's your home base. And then you got to find your jumpies, your jumpy numbers. Your jumpy numbers are default 1, 4, 9, 16, 25. They modify based on only the number that's in front of x squared. Nothing else matters once you get the vertex. You guys think you got it from here? I'll leave the recording going because I'm going to post this one up, because I kind of started my recording late, second hour, so I just kind of said I would do it later. So I'll leave this paused, and if you guys have any questions where I feel like, ooh, that's good for the recording, then I'll unpause it and post it up for whoever's absent today. So, all right, it's all yours. Have at it. So far so good. Haven't really done anything yet. I copied the problem. I wrote down A and B. All right, great. So what is the opposite of B? Yeah, it's just positive 8/3. So I'm going to write 8/3, and then I'm going to put it over 2 times A. And what is 2 times 1/3? Yeah, I hope that you know the answer and that you just don't want to answer, but I wish questions like this didn't vex us. If I say 2 times 1/3, that's just 2 over 1 times 1 over 3, which is 2 over 3. Like, I wish that didn't stump us. Or you could think of it as Marvin ate 1/3 of the pizza, but then the next week he ate twice as much pizza. Like 2 times 1/3 of a pizza is 2/3 of a pizza. Like, I want that to be quick for you. By the way, someone made an observation earlier. I remember, I don't think it was you, but someone made an observation that when you divide two fractions like this, do you notice how the bottoms of the fractions are the same? If you're not paying it, by the way, we're on problem 3. These ladies asked about it, so that's what we're working on. What's that? Yeah, you just get rid of them. And it's not because of like, Tom, or what do you call that guy, Harry Potter, like poof. It's not magic. It's this. It's because it's 8/3 times 2/3 flipped over like that, right? Just basic copy dot flop. So inevitably, when the bottom of the top fraction and the bottom of the bottom fraction are the same, eventually they're going to just cross out. So anyways, what's 8 divided by 2? It is 4. And of all the math that has taken place on the board, really the only thing we know right now is the x coordinate of the vertex, but it is definitely 4. Good so far? Okay, so now it's time to erase a lot of stuff to get some more real estate. So the vertex is at 4, comma, something. And that just means to take that 4 and put it there and there and hope and pray that nothing goes wrong. So when we put it in the first spot right there where I just circled what's 4 squared, what's a third of 16? See, I want to get you all to the point where you say the answers as quickly as Cooper does. And the deal is this. That's the goal, is to get us all where it just is like muscle memory. If I said to you, what's a third of 12, you should say 4. If I say, what's a third of 21, you should say 7. Like, that's just an expectation of a high school. However, when I say, what's a third of 16, why is there a pause? Because there is no nice third of 16. 16, as you know, cannot be divided evenly by 3. So your brain has to undergo this thing, and it should take under like a half of a second for you to realize that 16 cannot be divided by 3. So when I say, what's a third of 16, you should just instantly write 16 thirds. Because normally I would say, why write a division problem there? But in this case, well, because I can't come out with a whole number, right? So the first one is just 16 thirds, 1/3 times 16. If you want a better explanation, put 16 over 1 and then multiply straight across. And we're like, oh, I got the same thing. Now we got to go to the second purple circled X and put in a 4. And what is negative 8 thirds times 4? Listen, if there's any goodness that's going to come from this, if there's anything that's going to save us time, it's going to be those two red numbers being able to reduce. Can you reduce a 4 and a 3? Of course not. They're relatively prime. You can't divide 4 and 3 by anything. So in this case, all you got to do now is just multiply straight across. So you just go, I hope you're seeing that. That's 4 over 1, right? So if you just go 8 times 4, you get 32. 3 times 1 is 3. So the answer is just negative 32 thirds. Again, it is what it is. Get comfortable with fractions because they're not going to go anywhere. And then I got to add 4 thirds. We still good? Now, at this point, we're really hoping that things come out nicely. If I add all these fractions together, which of course I can because the bottoms are all the same, I go 16 minus 32 plus 4. What's 16 minus 32? It's not 16. That's a big difference. Yes, it's negative 16. And what's negative 16 plus 4?
20. I mean, no.
It's negative 12, which then if I put it over 3 is equal to negative 4. That's what it is. It's a minefield of basic skills torment. But when all of the smoke clears and you see it, you go, okay, finally, thank God I have a vertex. So now you're going to go on your graph to the point 4, negative 4. Which is right here. And you're going to put your vertex. So tell me about this graph. Does it open up or does it open down? Of course, yeah, the number in front of x squared is positive, so it has to open up like a bowl. The only way it's ever going to turn over like a McDonald's arch is if the number in front of the beginning x squared is negative. It's not, so it opens up. And what we're going to do now is figure out how far. So let me graph for you guys the normal graph. And this is all stuff that you'll see when, if you were not here, not if, but when you go back and watch the video, you will see that this is the basic default parabola. That is what the parent function looks like. It is built by going out 1, up 1. Look at these little purple lines I'm going to courteously draw for you. Are you ready? There's up 1, there's up 4, and there's up 9. And the only reason I'm not going to draw another one is because I don't have room to go up 16. So I'm out of room now. Now, this is a modified graph. So those red dots now have to take a dirt nap. Bye-bye. They don't have any place in this problem because the number at the beginning of the problem, the 1/3 that I am attempting to draw a box around, he says, I will modify all of your normals. So when I normally would go up 1, what is 1/3 of 1? 1/3. I would normally go up 4 for my second jump. What's 1/3 of 4? 4/3. Make it snappy. If you can't do the math, quit dragging your feet. Just make it a dang fraction and move on with your day. The next one would be out 3, up 9. What's 1/3 of 9? Next one would be 16. What's 1/3 of 16? It is what it is. And for the sake of graphing now, I realize it's hard as a kid. You're like, how come sometimes you do and sometimes you don't? I change things into mixed numbers when it's a place that I have to go to. If it was a slope, I'd be fine with 4/3. Go up 4, right 3, but this is not a slope. It's a place. So I take my 4/3 and I turn it into 1 with 1/3 left over. And I take my 16/3 and I make it into 5 with 1/3 left over. Someone says, take 4.5 steps. You go, okay, I don't really know why, but I'll do it. If someone says, take 9/2 steps, you look at them like they're like an alien, right? Like that's not how we talk about counting things. So we're going to go out 1, and then we're going to go up 1/3 of the way to 1, because that's what the modifier tells us to do. We're going to go out 2. How far up are we going to go? 1 and 1/3. I'm using that number that time. I've used up my out 1 up 1/3. I've used up my out 4 up 1 and 1/3. Next up is out. I'm sorry that I said that wrong. My out 2 up 1 and 1/3 I've used up. My next one is out 3. And I would normally go up 9. What am I going to do? I'm going to go up 3. So 1, 2, 3, 1, 2, 3. This is a super chunker. And I got room for one more because you know that I'm not going to go too far north. I'd have room for probably at least 2 more if I didn't get gooned by this right wall of the grid. But this graph being pushed so far to the east left us not a lot of room for eastward expansion here. So if I go out 4, I would normally go up 16. How far up will I go? 5 and 1/3. That's the beauty of that number. I just circled it for you over there on the right side. That number is huge. He's 1/3 of the normal. So I go out 1, 2, 3, 4, up 1, 2, 3, 4, 5, and 1/3. And then you try to make a graph. You do not need to continue with points on the inside, but it's honestly pretty good practice if you want a better graph. So like I could do another one. I could come make another point, like it'll be around in here someplace. So does that clarify with you guys? You sure? Okay.
Look at the graph on that.